So, good evening, ladies and gentlemen. Gianluca Massi speaking on the behalf of the Virtual Telescope Project. And it is really a privilege for me to be here tonight, going to share live something very special, something we have been reading about these days quite a lot. And now we are ready to share with you in real time images of the potentially hazardous asteroids 1994 PC1. I am the founder and the scientific director of the Virtual Telescope Project, and I really want to welcome you from every part of the globe. I see that we have really a lot of people looking forward to have a personal view on this asteroid. Before I start, I want to thank the technological partners of the Virtual Telescope Project, and they are Software Bisq, Unitron Italia Instruments, C-Web, Santa Barbara Instruments Group, Planewave Instruments, and Bader Planetarium. That said, I really want to start sharing images right away, and then we will be commenting together what we are seeing. We will be discovering what asteroids are, but first of all, I know we are here just to have fun with the live view, and the telescope is ready, weather is good, and so just let's start looking up. Here we are with our system controlling the telescope, and over the years we have been really doing a lot of things with our robotic systems, and right now I'm really happy and ready to share with you, as I said, this asteroid. This software is actually our console to properly control the whole system, and we are really going to ask the telescope to point the object and to track it at our best, my friends. That said, we are really asking the system to slew and observe the object. Here it is, the asteroid. This is as you can see in the western side of our horizon. This star map is just telling you which stars are above the observing site. I want to make clear that our observatory is located in central Italy. We are about 100 kilometers south of Rome, and we are actually controlling the robotic observatory from here. The observing site is completely unattended. No humans are there, and we are really trusting our technology. And if you look at the star chart, you could ask yourself where we are looking. Of course, this is a very huge sky, but this star chart, the Sky X Professional Edition, is from Software Bisq, is helping us just locating with this yellow crosshair where the telescope is looking in this very moment. So we are looking here, we are here in the sky, while the object, Asteroid Minor Planet 1994 PC1, is not far from here, but we still need to slew and track at its apparent rate. I just asked the telescope to go, and here you can see our telescope moving, by the way, with the full moon just on the background, and I hope that this quick sharing here will add some realistic feeling to your otherwise virtual observing section. That said, to be a very good astronomer, I will switch our local lights there off to be in full darkness, or well, to what a full moon is making possible for us. And at this very moment, we can ask our webcam to sleep for a while, and I asked the telescope to point where the asteroid is, and now I want to frame a bit better just in the direction, just a portion of the sky in the Cetus constellation, that is the whale where we are. But not only I asked our robotic telescope to point the object, at the same time I asked it to track at its apparent fast rate across the stars. I want to take just a quick image to make clear that everyone here is understanding the beauty of this and what is happening. So the asteroid is up there, the telescope is pointing the object, but we are also tracking it because this asteroid, being relatively close to us, has a very evident apparent motion against the starry background. And here we have the right technology to track at any rate, including this one, which is fast but not spectacular as object we tracked in the past. That said, let me just ask the system to take a quick preview image. It is time to do greetings, and you are here to spot the asteroid. And I start with this short exposure, that is, I am collecting for a handful of seconds the light coming from the right spot of the sky where the asteroid is. And the question will be, what is the asteroid? Just taking a very quick calibration image. And I'm also adjusting brightness and contrast in the image because, as I told you, we have plenty of full moon out there. And right now you have a number of dotted lights. They are stars, and somewhere is the asteroid. It is easy to recognize the asteroid because, as you can see, we are taking images, a series back to back. Look on the upper left, the countdown is running so fast. Every 5 seconds we have a new image. And look here, you see just one sharp dotted light, while every time a new image is uploaded, you can see the star as sliding, slowly moving to the upper left. In other words, the swan, the object we see in the center, is the asteroid, and I hope that my mouse now will help you locating it. This is the asteroid, and all the other ones are the stars in the background. My friends, that is the long-awaited asteroid 1994 PC1, and we are very, very proud and happy to start sharing with you these live images, and really hope that you are just enjoying this start of the experience. I told you, we are really observing live images. That is happening all the times, every time, with the virtual telescope project. And now I want to take a few more spectacular things, because as you can see, a few seconds are enough for this object just to take just to leave a trail. I want to take a few shorter images. I will use them for some science later on, just calculating to find a very exact position of the object, and this will help, of course, just with the orbit calculation. I need to adjust contrast and brightness because I really changed dramatically everything here. These are images. Here it is the asteroid. Oh, there is also a satellite crossing the field of view, and of course the asteroid should be this one in the very center, or there is this one, sorry. And I will take 5 of these images, and then I will want to make you saying wow when I will try to take a longer exposure image, and you will understand why I believe you will say wow. So we are just waiting for the 5th image of this quick series, and once the image will be shown, I will ask the system to start having fun together. These quick images will be used for some science later on. Now, we are still tracking the asteroid 1994 PC1, these 1 kilometer large potentially hazardous asteroids. I will tell you a bit more about these definitions, but I still want to start right away such a 30 seconds image. That is, while we are tracking the object at its personal apparent motion, we are collecting light for 30 seconds, and this will leave enough time to the asteroid to move significantly, and the stars should look as very long trails. This is a potentially hazardous asteroid. This doesn't mean that it is going to hit us. Potentially is the key word here. That is, it has the potential to be of interest under the impact point of view. To be honest, every asteroid just satisfying 2 basic conditions is flagged as potentially hazardous asteroids. After all, to be hazardous, you have at least you need to be large enough to make a lot of damages in case of collision, and of course you have to come close enough to me. So these couple of definitions are helping to fix what a potentially hazardous asteroid is, and scientists decided that every asteroid larger than 140 meters and able to approach the Earth orbit within 7.5 million kilometers can be flagged as a potentially hazardous asteroid. And our object, 1994 PC1, is big enough, 1 kilometer. Well, it is much bigger than the threshold required by the definition, so it's a huge asteroid for sure. And it is able to come closer than 7.5 millions of kilometers from us. And right now, while we are approaching in about 1 hour and a bit more, it's the flyby, it will be about 2 million kilometers from us. Let me say this clearly. There are absolutely no risks of collision. 2 millions of kilometers are really a lot, of course, my friends. And they are 5 times the average lunar distance, just to give you an idea of the distance from us, between us and this intriguing object. But being that large, about 1 kilometer, sorry, and that close, about 2 million kilometers, it is very bright. And if you have a small telescope with 4-6 inches, that is 10-15 centimeters in diameter, you can really try to have a look, provided you know where to point the telescope. And here our software, the Sky X Professional, for example, is so beautiful, just supporting this kind of task. But happy that we are having fun, as I said, with our own robotic telescope. And by the way, I want to show you again the telescope we are using for this task in this very moment, my friends. And here it is. Let me share just an image of the telescope so that you know who is who. This is the telescope, friends, we are using for this. It is an amazing telescope with high-end technology, making possible to track, as we are doing, this intriguing object. Back to live images, and as you can see, 1994 PC1 is the sharp dot of light you see in the very center. The telescope is tracking beautifully this object, and as I told you, it is already very close to its nominal minimum distance, that is 2 million kilometers, a bit more than 5 times the average lunar distance. So it is far enough, incredibly, it is close in reality if you compare this to the typical asteroid distances, but it is still a huge distance, so nothing to worry about. This is very important to say. I also want to add another detail, that is this object is spinning around its axis, and it takes a bit more than 2 hours and a half to complete a rotation. So I find also intriguing to say that the typical length of the day is just 2.6 hours, 1/10 of our day, more or less. So I'm very happy that this live coverage is offering the opportunity to see this object to so many people around the planet. And every time an image is uploaded, you can see the stars are shifting, are apparently moving to the upper left. This is because the asteroid is moving across the stars. Of course, stars, and our ancestors called those stars fixed stars, are actually moving themselves, but it takes a lot of time that in our lifetime we cannot see any difference in the sky if you don't have the right instruments, to be honest. But the asteroid here is close enough that this can be seen seconds after seconds. And to make things even more spectacular, let me try using now a 2 minutes long exposure. While we are waiting, I want to tell a bit more about asteroids. Let me show you a few things. First of all, by the way, I want to show you how this asteroid is moving in the sky, and right now it is in the Cetus, the whale, and it is moving to the fishes, then it will move to Pegasus, the winged horse, and then Andromeda and Cassiopeia, but it will take a couple of days, and you can find this map on our website if you really want to try these very hours to spot the telescope yourself, the asteroid yourself with your own telescope, as I told you. And we know a lot of asteroids. The first asteroids have been discovered in 1801 from Italy. It was asteroid number 1 Ceres, but actually it is a dwarf planet. Anyway, such a beautiful story about asteroids started on that night in Palermo, southern Italy. But in a bit more than 2 centuries, we became so good hunting and discovering asteroids that now we have about just an order of magnitude 1 million asteroids. And if you just take a snapshot of the solar system with all those asteroids, you will have such a situation. You can see the sun in the very center, and here in this plot, the orbit, the largest orbit you see on the outer orbit is the planet Jupiter, and you can see there are many asteroids between that orbit, Jupiter, and the one of Mars. And that dense region with asteroids is the so-called asteroid belt, and there most of the typical asteroids are living without any trouble for us. By the way, here you can see also asteroids on the Jupiter orbits. They are the so-called and very important Trojans, by the way. But you can see that there are asteroids even among the inner orbits, that is Venus, Mercury and the Earth. And it is that portion of the world population that is a reason of concern for us, because we now know for sure that asteroids can really approach the Earth orbit. They can even cross the Earth orbit, and they can even collide with us. Meantime, let me show you again what the telescope is doing now with 2 minutes exposure, much longer star trails. Anyway, back to this. So asteroids are for the largest part concentrated in the asteroid belt, but with a significant fraction moving in the inner solar system, and they are the so-called near-Earth asteroids. And among the near-Earth asteroids able to reach the orbit of the Earth, there are the special sub-category, I will call them this way, of the potentially hazardous asteroids, that is larger than 140 meters more or less, and able to come closer than 7.5 millions of kilometers. If you are that large and you are able to come that close, you are a potentially hazardous asteroids. And of course there are many different objects belonging to this to the family of near-Earth asteroids, and they are the Apollo, the Aten, the Amor, and also the Hera, that is the inner-Earth objects, depending on the shape of your orbit and if you cross or not the Earth orbit, or if you are with your orbit completely inside the Earth orbit. These are the four types of asteroids you can have when you are just studying near-Earth asteroids. It is not enough to say near, but you have to consider if the orbit is crossing or not our own orbit, and if the asteroid orbit is outside or eventually entirely inside the orbit of the Earth. Of course, these numbers, especially the EAO, are now more than 6, but the plot, that is the orbits here, are absolutely of interest while we are just talking together about all those things. Back to the live observing, here we are, and you can easily understand that once we discovered that asteroids can cross our orbit and they can eventually impact with the Earth, it is very important to do our best to avoid that scenario. We want to do the same tragic end of dinosaurs, and we had the opportunity, we had the technology to probe the skies, scanning up there among the stars, and hopefully locating as much asteroids, near-Earth asteroids as possible. And there are special telescopes on our planet doing this every clear night, and they've been very productive. And I want to show you this plot from the JPL, where you can see the up to date. Basically, we know about 30,000 of near-Earth asteroids, and in 10%, that is almost 3,000, are potentially hazardous asteroids, and a bit less, almost 900 asteroids of near-Earth asteroids are larger than 1 kilometer. That is, just to summarize, almost 30,000 asteroids able to come close enough to our orbit, the Earth orbit. And among them, 10%, about 3,000 of them are larger than 140 meters and coming closer than 7.5 million kilometers to be called potentially hazardous asteroids. So 3,000 of these objects. And we have also about 3,000 of potentially hazardous asteroids, and we have about 900 of near-Earth asteroids larger than 1 kilometer, and we really don't want an asteroid of that size, like the one we are observing together, having an impact with us, because it will be a big problem for us, with likely also catastrophic results after the impact, of course. Back now to the asteroid. Here it is. Our telescope is tracking these objects so beautifully. We are very proud to have the right technology to track such asteroids, and we have been doing these things many times, my friends. Every time an asteroid is around, we are very happy and proud to point it with our telescope and offer to the community the opportunity to have a look live. Of course, pending the weather, provided we have a clear sky, and this is not obvious. We are just in the coldest fraction part of winter here in Italy, but luckily, at least tonight, we have a very clear sky. And here it is, our asteroid 1994 PC1, beautifully tracked image after image by our system, my friends. I hope that this is bringing to you the feeling of the live experience. Of course, technology is making possible something unique, something special. You are where you are, at home, very likely at your desktop, sitting at your desktop, and in your living room. I am sitting in Rome in my office, and the telescope is 100 kilometers south from me. Nobody is there, so everyone is in a different place. The telescope is there. I am here controlling the telescope and sharing images and commenting images with you, and you are at home, wherever you want, wherever you like, looking at this. This is amazing. The bright side, the good side of, as I told you, of technology, and I'm so happy that this is possible thanks to our project, and you are invited, if you want, to support our project by donation visiting www.virtualtelescope.eu, as we just survived thanks to this. We are not asking, money to explore and enjoy the beauty of the cosmos. The sky and the beauty of the universe belong to everyone, but of course there are electricity and so on to be paid and covered. So if you really want to support, consider donating on our website. Thank you very much. We are still live, as you can see, just enjoying a few images, and I also want to share with you, if you don't mind, this quick video I did last night in order to see. This is of course running much faster than in nature, but at least you can really have an idea of an asteroid traveling. And I did this yesterday, and of course some post-production is needed to put together many frames to give you the idea of such an animation. And I was happy, and I'm happy to share this with you, my friends. But you could be also interested to learn about the orbit of this object, and I will do this. I will share the orbit with you right now, and you can see here the inner solar system, the Sun, Mercury to Mars, and you can see the Earth orbit, the third one from the Sun, and you can see also the asteroid is very close there to our planet. Let me see if I can also share another image with you, just with the orbit of the object properly marked, and I will be honestly happy to do that in real time. And I really love the software controlling our robotic telescope, the SkyX Professional by Software Bisq, as it also gives you the opportunity to plot the solar system at any moment. Let me see if I can do this right away with you. Here we are. So here you can see the orbit right now of the asteroid. You can see it's a clearly elongated orbit around the Sun, and happy that I could show this right away. This image was not ready, and I did this simulation right away with our software, and so that you can see what is the orbit of the asteroid around the Sun. And right now you see the asteroid is very close on its orbit, where the Earth is on its own orbit, and we are lucky that the asteroid is just 2 million kilometers from us. That's it. Back to the live feed again. Here it is, 2 minutes exposure, and the asteroid is slowly approaching. And another things I want to say, it is the relative speed of the asteroid relative to the Earth is about 20 kilometers per second, so it is a pretty fast object. I don't know where it is going so fast. Perhaps it has a very important meeting somewhere. But that is. I just want to check the weather. Okay, the weather is just great, so really no problem for us. And I'm happy that the sky here is doing its job, cooperating. During the winter, you never know. We had several events we were forced to cancel recently because of the weather. And I also want to share with you now, while waiting, where we are in the sky. Just asking to our software controlling the telescope. Here we are to show where we are. I love the flexibility of this system, and you can see that right now the yellow crosshair is where the telescope is pointing. That is where the asteroid is second after second, and we are just crossing the border between the Cetus constellation, the whale, and the Pisces, the fishes. And Pisces belongs to the zodiacal constellations, and perhaps you know their name pretty well for non-astronomical reasons, of course. But here we are, and the object is really moving fast, and for in the next days it will move, even reaching here Cassiopeia, moving this way, crossing Pisces, crossing also these other important constellations. How beautiful all this is, sharing these amazing things in real time. And back now to live images. We are using this very exclusive technology, making possible for us to track at any rate, including crazy asteroids and more. Over the years, we really tracked the asteroid much faster than this, much closer than this. A few years ago, it was, if I remember right, 2013, we observed the asteroid 2012 DA14, and it was closer than geostationary satellites at the time, and it was a terrific experience, very exciting, and provided there are no risks of collision, it is just fun, you know. And I really want that you understand that we are tracking the object. The telescope is tracking at the real rates of the asteroid. This is why the asteroid is so sharp, while the stars are left to slowly slide, to slowly move and leave those long trails while we are observing. So happy really that everything is working beautifully, and that the virtual telescope once again is sitting on the front line and giving you the opportunity to have fun, to enjoy, to see something unique, as in this very case. If you really want to stay up to date, if you really want that every time we do something special, you will know, you can join. I strongly suggest you to subscribe our Facebook page, the Virtual Telescope Project. Easy to locate there, and this way every time something new will show in the sky, and very often things are organized at the very last minute, because perhaps while we are speaking another crazy asteroid is just discovered, and possibly we will schedule a live feed covering and sharing it with people. And if you really want to know what is happening, what is next, you can visit our website, of course, www.virtualtelescope.eu, but it is also very useful to subscribe our website, our Facebook page, where we can update you in a matter of seconds. Now I want to stop taking images at this rate, and I want to try to take at a faster rate, just to give you a faster refresh, and I will ask the system to calibrate the image in a different way. I apologize, there are many things I'm doing so fast thanks to experience, but I'm basically taking a shorter exposure, longer exposure, and asking the system to calibrate, quickly calibrate those images to offer us the best view, hopefully. Very likely I will need to adjust contrast and brightness, because I changed dramatically the imaging parameters. Not that much, and here it is, the asteroid in the very center, and with the 10 seconds you see the object is now still sharp, but the stars have much shorter trails, because we are leaving them just 10 seconds, not 120 as earlier, to leave their trail, by the way. Image after image, this is updated, and I find all this fantastic, to say the least, my friends. I'm really amazed to see that so many people have been waiting for this live coverage to join, to have fun, to explore and probe the sky together. And the virtual telescope has been around since 2006, so it is getting older and older, but the Earth is young, the technology is cutting edge, and we are always ready, thanks to our technological partners, Software Bisq, Unitron Italian Instruments, C-Web, Santa Barbara Instruments Group, Plainwave Instruments, and Badr Planetarium, to bring the best experience to you every time. And by the way, we are ready to announce a huge improvement, something I would call a breaking news. So stay tuned, because we are working to announce something which will really improve a lot our possibilities to bring the beauty of the sky to you. So stay tuned. I cannot add more, because it is still a work in progress with very special partners, and when everything will be ready, we will of course share with you such an important upgrade. Meantime, 1994 PC1, this 1 kilometer large potentially hazardous asteroid, is peacefully and safely flying across the stars, while we can see here, let me see if I can just scale this window. Okay, so that yes, we have the image of the object, but we can still see here on the left where we are pointing the telescope. The object, the target, is moving west. It is going to set, and at some point I will take a break with my voice, but I will leave the live feed opened, and I will be back in 25-30 minutes more or less. But I will just put the right advice to make clear you understand this, and in case you can you can continue to observe the sky with us, and we will see later, we will comment later. I mean, it is not easy for me to speak in English. I will do my best. I apologize for my English, which is far from being perfect, but it is not in Italian. But I understand that you are out there, not in Italy, very luckily, part of you, but the largest fraction are abroad, and I do my best to bring this to you, but still I apologize for my Italian English, as I like to call it. And really hope that you are enjoying the experience, the virtual observations of the potentially hazardous asteroid 1994 PC1, which is right now very well visible from Europe, from Italy in this case. And I hope that it was for you a nice opportunity also to discover the beauty of the sky. I'm very happy when a huge astronomical event just capturing the attention of the media is around, because we have the opportunity to invite people discovering the sky. Yes, these are mainstream events, I understand. Not every day you have something so special, but trust me, if this is for you, if this asteroid will help you just feeding your interest and curiosity in the night sky, you will be never disappointed, because the night sky is full of beauty, is rich of haze, and every night could be the right night to start your unique and amazing journey, my friends. Now I just, as I told you, I want to take a little break, and I want to update this. We will be back in about 30 minutes. Just to take a quick stop to recover a bit with the voice, but I will be back very soon. So stay tuned, and I will leave live images coming, as you can easily understand looking on the upper left of our system. And as I told you, I will be back in 30 minutes by now. See you later, my friends, and keep looking up with our system. And here we are back with our audio comment. Thank you for waiting this quick break. And again, the system is beautifully tracking the potentially hazardous asteroid 1994 PC1. And at the same time, the rotation of the Earth is slowly bringing this object, which is moving pretty fast across the stars. It is moving, I said the Earth rotation, it is moving this object in the western part of the horizon. And as you can read here, this is a very precious software. You can see that the telescope is now pointing at about 24 degrees above our local horizon here in Italy. And it is amazing that all these kind of details can be shared with you thanks to this technology, my friends. And I really do find all these very nice, having the opportunity to bring to you something special, something unique as tonight. I plan to stay tracking this for a little while, as I see that many people are joining right now our live feed. And I really want to thank everyone. Our website is doing its best to support every friend joining. And as I said, the Potentially Hazardous Asteroid 1994 PC1 is the sharp dot on light here, because the telescope is tracking at its apparent rate. Now I want to adjust contrast and brightness. So the telescope not only was asked to point the asteroid, but it was also asked to track while it is moving across the stars. So the stars are leaving those little trails on the background. As I told you, this is a potentially hazardous asteroid, and the most important word here is potentially. It is just means that it is not going to hit us, just bringing a lot of troubles for us. Potentially hazardous asteroid is just a very precise definition. Every asteroid larger than 140 meters and able to come closer than 7.5 millions of kilometers is flagged as a potentially hazardous asteroid. So it does not mean that it is going to collide with us, but for sure, being larger than a given amount and coming closer than a given threshold, it is a good idea to keep an eye on that object, you know. And as I told you, the minimum distance will be touched in about 40 minutes, and at that time the asteroid will be a bit more than 5 times more distant than the average lunar distance. So that is 2 million kilometers. So it is not close, very close, I mean, but it is still close compared to the typical distance of the asteroids living in the asteroid belt. And this is why such a close encounter is of great interest, because it is relatively close and the asteroid is large enough to be quite bright. And if you have a little telescope with a diameter of 4-6 inches, that is 100 and 150 millimeters, you can hopefully try to give it a try, provided you know where to look for it. And in this case we are using the software the Sky X Professional, which is actually controlling the whole robotic telescope, and but it would be very useful to locate where the asteroid is in a given date and time, and so that you can try to point your telescope there. And if you can, give it a try, because you will see the object moving in real time, my friends. And it is a very, very unique opportunity, I believe, and it is not happening every time, every day. This is why I strongly suggest you, if you have the opportunity, to give it a try, as I told. The asteroid here, let me see if I can just enlarge. We are just crossing the border here between the Cetus, the whale constellation, and the fishes, species, and the yellow crosshair is just saying us where the telescope is pointing in the otherwise very large sky. And as we ask the telescope to point the telescope of the asteroid, of course, we are where you see the yellow crosshair, we also have the asteroid, and the telescope is tracking at its very personal rate, my friends. I really hope that you are having fun with all this, and I want to remind you that if you like what we do, we can consider the possibility to support us donating whatever you want by visiting www.virtualtelescope.eu. That is our official website, and from there you can really decide to help us paying bills and similar things. For us is always a privilege to bring to you these very unique, very special cosmic events, and I'm happy that tonight weather is cooperating, because recently we had an event we were forced to cancel because weather was absolutely bad. And tonight we also have the full moon, but luckily the full moon is in the opposite direction, so it is not giving too much interference. And we are also quickly approaching the horizon, the western horizon. I will try to stay live for 30 more minutes, and just to cover possibly the flyby. And let me also see. Perhaps we will try. Even if you can see now images are getting brighter and brighter, because there are some in the sky so low above the horizon, and the full moon, of course, is just creating a serious interference because of that hazy sky. But we are still here, we are up and running. And again, I want to remind you that this is a very special asteroid. This is a potentially hazardous asteroid, just saying us that it is larger than 140 meters and coming closer than 7.5 millions of kilometers, and there are about 3,000 asteroids having those characteristics, but this one is quite large, about 1 kilometer, and we really don't want to have a collision with an asteroid that large, which will cause a serious issues for us on this planet. And this is why it is very important to scan the skies with advanced telescopes, trying to locate as much as possible of those asteroids, and evaluating the impact risk, and in case should we find a very bad asteroid, a solution, for example, just changing its original trajectory, like the DART NASA mission will try to do later this year with the asteroid Didymos and its satellite. We are always tracking the potentially hazardous asteroid 1994 PC1. And as I said, while we have 30,000 more or less of near-Earth asteroids, and 10% of them are potentially hazardous objects, we still have about 1 million asteroids out there, mainly in the asteroid belt between Mars and Jupiter, and from there they really are safe objects for us. Up and running, as I love to say, with thousands of people tracking our live feed, and I'm very happy that we could support this way your interest in the night sky. I strongly suggest you to join the Virtual Telescope Project Facebook page to be up to date every time something new is happening, something new is showing up there. If we organize something, we are going to advise, to tell to our friends, thanks to that channel. And I love how technology can really help us with this task, that is bringing the beauty of the night sky to everyone across borders. Something we have been doing since we started activities in 2006. And we are getting slowly, well, not so slowly, getting older. And I want to share with you, while we are still tracking the object, some images I showed earlier. For example, if you imagine to leave our planet, imagining to grab a snapshot about the solar system, the inner solar system, you will see this one. That is the outer orbit is planet Jupiter, and perhaps you can see the fourth orbit from the Sun, which is in the center, that is Mars. And between Mars and Jupiter you see a lot of asteroids, and that is the so-called asteroid belt. I also want to underline that you have asteroids on the Jupiter orbit. They are Trojans, and they form a 60 degrees angle seen from Jupiter respect to the Sun, and they are very precious and very important as for the dynamics in our solar system. But I want to underline how many asteroids you see in the inner solar system, in the asteroid belt. But of course those asteroids are giving up troubles, but unfortunately from time to time an asteroid can leave the asteroid belt under the perturbation of Jupiter, for example, but there are other dynamical mechanisms in action, and such an asteroid can be delivered in the direction of the Earth, pushed in the inner solar system, just becoming an Earth crossing asteroid, and in becoming of course a very different object, and perhaps even dangerous. So there are very intriguing dynamical mechanisms in action in the solar system, just creating, I would say, by dynamical evolution, the near-Earth asteroid population. And Jupiter is playing a primary role under this respect. And here you can see also that there are asteroids you can see in the inner solar system, where planet Venus and planet Earth are moving around the Sun. You can see there are many dots there. They are the near-Earth asteroids. So you can see that it is a real topic, and from time to time an asteroid can come very close and eventually having an impact with us. This has happened many times in the Earth history with the dramatic effects sometimes. Unfortunately, dinosaurs did not survive directly to tell us about the events they could see, witness personally, but we really don't want something like that happening again. This is why there are several telescopes around the planet scanning the skies every clear night, mapping the near-Earth population at the best possible, made possible from technology. And there are also scientists calculating orbits just to evaluate the impact probability for every object we know. Let's go back now to the live view. Here it is. And I really hope that you can really have the same excitement I have. And the technology here is doing something great, because as I told you, I am in Rome. The telescope is alone 100 kilometers south from me, and you are where you are. So this is truly a remote, under many respects, and technological happening. And this is the good side, the bright side of technology, my friends. Look here, you have also artificial satellite rail, and we will try to identify later on tomorrow which object crossed the field of view while we were doing this job together. As a professional astrophysicist, I'm always amazed to see how an asteroid can really capture imagination of the public, and this is why I love those objects, because every time an asteroid is approaching, people want to learn more. Of course, first of all, people want to learn if something dangerous is going to happen. We are lucky that this is not happening that often. Also because many asteroids are much smaller than this, and actually there are, I would say, some kind of asteroids, let's call them that way, that we are happy to have, and they are those teeny grain of dust, just making possible for us to enjoy meteors, for example. After all, they are very microscopic asteroids entering the Earth atmosphere. So if they are that small, we are just happy. We want them to enjoy meteors, but if they are larger and larger, well, the situation, the feeling change quite very quickly. To the point that we really don't want to discover the asteroid, the Sirius asteroid, going to collide with the Earth. I don't know any astronomer, I don't know any colleague looking forward to announce to the world that he has or she has discovered the killer asteroid. Let me adjust contrast and brightness a bit. Now the hazy sky is helping the very bright full moon, making harder and harder to spot and spy this. You can see that now we are approaching 20 degrees here above the horizon. This is pretty low. At this low altitude, telescopes are often looking far from this low altitude, because there are several negative effects of our atmosphere just affecting the potential data. But here we are tracking an object and we are not doing anything serious as from the scientific point of view, and so we can go anyway. We can even observe when we have scientific needs, no matter the altitude, if what we are going to see is precious and rare. I did that many times, but the lower you look, the stronger the effects of the atmosphere. For the same reason you see the sun by naked eye without burning your eyes when the sun is rising or setting, you see it red. So the atmosphere is absorbing light in a selective way, and it is not it could be a problem when astrophysical needs are involved, if you are observing with some scientific goal and needs, as I said. We've been running now for 1 hour and 30 minutes, and I see many friends connected, keeping an eye on this marvelous rock. I have seen a lot of announcement by the press, the international media, telling about this approach and correctly underlining that it was a huge event, because this object could be seen with your very personal telescope if you know where to look. And again, perhaps it could be nice if we just show the star chart I made. Here it is, showing the path of the asteroid for the next days, when it will be within the possibilities of a small telescope. The nominal flyby will be in 20 minutes, and I plan to track this object for those 20 minutes. And here, as I told you, you can see the path in the sky of this object. And if you adjust the resolution of your YouTube stream, you can perhaps read the numbers. But the interesting thing is this every dot is marking the position of the asteroid every 6 hours, and the asteroid is moving from the lower left to the upper right, by the way. And you can see that even every 6 hours, the distance between the points taken a regular interval of times, the distance is different. And when the distance at the same interval of 6 hours is larger, it is where the asteroid basically is closer and apparently moving faster. And this is something I really want to underline and help. And we are now leaving the Cetus, the whale constellation, entering the Fishes zodiacal one. Back now again to the live feed. Here we are. How funny for us is to observe and share with people worldwide these amazing things. I forgot how many times I shared an asteroid with the community, hundreds of times since the virtual telescopes project started operations, and we can do this thanks to technology involved, and we are using truly cutting-edge technology provided to the virtual telescope project by one of our technological partners, Software Bisque, and we are tracking so beautifully thanks to such a technology. And this one is getting brighter and brighter. And we are now at 20 degrees, and the light of the asteroid is reaching our telescope after traveling a very large amount across a very large amount of our atmosphere, which is strongly affecting what we are seeing. And the sky is quite hazy when you look low above the horizon in this cold season, and the bright full moon, of course, is just adding its own troubles. But here we are, and I really would like to stay live for a bit more. And now we will switch again the audio off for a few minutes. Being back in 10 minutes, my friends. So stay tuned so that just want to make sure that our friends will know that we will be back on time to comment the flyby. See you later, my friends. Keep looking at the stars and the asteroid live with us. And we are back a bit earlier, as I really want to stay with all of you friends while we are slowly approaching the nominal time of the flyby. In 9 minutes from now, the potentially hazardous asteroid 1994 PC1 will reach its minimum distance from us, and at that very time it will be at 1.98 millions of kilometers, so marginally less than 2 million kilometers from Earth's center. And this is happening, as I told you, in 8 minutes now. I hope that the sky will stay clear while we are really approaching very low altitudes above the horizon. At this altitude, 18 degrees above the horizon, of course, it is very hard to take regular astronomical observations because atmosphere with its absorption, its the extinction, and also turbulence and reflection are really giving a lot of troubles to the light of this poor asteroid. And I'm really amazed to see how, no matter all these extreme physical difficulties, they are part of the physical structure of the atmosphere, of course. Our telescope is doing its job flawlessly and amazingly. And as I told you, we are about 7 minutes away from the nominal flyby with this 1 kilometer large asteroid, potentially hazardous asteroid 1994 PC1, which had a great attention from the international media, and I'm very happy for that, because this gave us the opportunity to bring some ideas, some flavor about the asteroid science to you. And if you really want, very likely those joining this live feed now have missed the introductory part, and if you will have time, I suggest you to rewind and restart this at some point, just to learn a bit more about asteroids, understand why they're important. And by the way, I want to add that asteroids have a primary importance because they are the most pristine material survived around the sun after the solar system was born, and basically they are the bricks which made the planets we see today, Earth included. And after all, when an asteroid is just posing a threat of collision with the Earth, it's just reminding us that collisions in the very past of the solar system had a primary role building asteroid after asteroid the precious planet where we live. So if we want to study the prehistory of the solar system, asteroids are perhaps the best place for you to start such an investigation. And in the future, in very near future likely, asteroids will be also primary sources of precious prime matters, and they will be, we will see mining asteroids, people mining asteroids and companies mining asteroids, very precious resources will be brought to the Earth from asteroids, and they will be very exciting times for us to live. And we are looking forward to see that as well, while 5 minutes are left before we can wave at the asteroid 1994 PC1 slowly approaching and safely coming basically at the distance of five times the average lunar distance, while its speed relative to the Earth is quite high, about 20 kilometers per second. This is quite high. And I really want to thank all the international media which shared the opportunity to join us tonight. And I want to thank all of you for being with us, for giving us some of your time. This is something I really appreciate. When someone decides to give you her or his time, it is an honor, because time is unique in our life, and I want to thank you for spending some of your life with us, actually looking up and tracking this very beautiful and interesting body. I see so many people, thousands and thousands of curious people virtually looking us together, no matter borders, no matter time zones. We are just the same people enjoying the beauty of the cosmos, the same cosmos we share and we enjoy and we love, with special attention for asteroids. And image after image, you see how our system is upgrading, uploading what we are seeing. It was a beautiful live feed for me, an honor, as I told you, to tell about this asteroid and bringing to you no less than real time live images of this space rock, Potentially Hazardous Asteroid 1994 PC1, now a couple of minutes apart from its long-awaited flyby, which is quite a gentle close approach, with the asteroid staying a bit more than 5 times farther than the lunar distance on average, so by no means it was a dangerous approach. If you have read that this asteroid was an issue for us, don't visit that website any longer, because they are just lying to you. This one has been always, for sure, a very safe approach. I told you this object is its distance is 5 times larger than the average lunar distance, sorry. And here we are, 1 minute far from the close approach, and I'm very happy and proud that we could run flawlessly for about 2 hours now, and having fun with this object, enjoying the beauty of the sky and so on. And let's hope that it was beautiful for you to join this experience, useful, interesting. And my friends, right now, the Potentially Hazardous Asteroid 1994 PC1, it is at its minimum distance from us. That is barely less than 2 million kilometers from us, a bit more than 5 times the average lunar distance. And it has been a privilege, really a privilege for me to bring all this to you. And the telescope really gave an outstanding demonstration of its technology out of this world. We have been tracking at a very specific personal motion rate of this asteroid, and we tracked it so far without troubles, and so proud and happy to acknowledge here our technological partner Software Bisque, providing the technology, the hardware and the software technology to track this beautiful, interesting object we have been waiting so long to show and share with you worldwide. And at this point, I'm really going to close this almost 2 hours long now live feed. And as I told you, it has been a real privilege for me to be live, and I hope that your time with us was rewarded with excitement, with enjoyment of this intriguing astronomical event. And if you would like to see more, I strongly suggest you to join the Virtual Telescope project more often, regularly. You can visit our website www.virtualtelescope.eu, or you can even subscribe, perhaps the faster, easiest solution, the Virtual Telescope project page on Facebook. If you liked what we did, You can even consider to support us. We really share all this for free. There is a lot of work behind the scene, you can understand, bills to be paid, maintenance to be done, and you are very welcome if you can to support us by donations. It is easy to do. Visit www.virtualtelescope.eu and go to the donate section, and we will thank you, sending you some exclusive digital images you can enjoy, you can print, frame and put on the walls of your preferred room if you want. That said, Gianluca Masi, astrophysicist, owner, founder and scientific director of the Virtual Scarlet Telescope, is thanking all of you for joining, for being here. Many thousands of people are connected tonight with our live feed, and I also want to thank our technological partners. They are Software Bisq, Unitron Italia, Badr Planetarium, C-Web, Santa Barbara Instruments Group and Planeweb Instruments. Take care of yourself, keep looking up, and never forget that the Virtual Telescope here to support your interest in the stars and giving you the opportunity to live for these amazing journeys. Thank you, take care, and stay tuned with us.